Hi, everybody. Welcome to the Math 60 video lecture. This is section 3.8, and it's about four important types of lines that don't show up as often. And those are vertical lines, horizontal lines, parallel lines, and perpendicular lines. So quick look at the graphical for each of these. I'm not going to worry too much about numbers or scale. I just want to show you what they look like. Vertical lines, straight up and down. Horizontal lines, straight across. Parallel lines are two or more lines that are always the same distance away from each other and never cross. And perpendicular lines are two lines that come together at a perfect right angle, right? So that it's a 90-degree angle when they touch. There's no, it looks like a perfect X where they cross. So this is our pictures representation. Let's build a table for each of these. Let's suppose that number right there is -2. So if you notice, everywhere on this line, the x is -2. It's -2 when y is 0. It's -2 when y is 1. It's -2 when y is 2, and when y is -3, even when y is 1,000,000, the x value is still -2. So a vertical line always has x equal to -2. Horizontal line, well, let's call this height right there 3. So notice when x is 0, y is 3. But also when x is 1, y is 3. And when x is 2, y is 3. And if x is -5, y is 3. And even if x is -1 over 100, y is 3. So in a horizontal line, the y value is always a constant number. Parallel and perpendicular lines, the table representations aren't as informative, so I'm going to skip those. But it's important to notice that since the x value is always -2, I can write the formula for a vertical line just by telling you what that x value is. X is -2 no matter what y is. So x equals -2 is the equation for a vertical line that touches at -2. And in my horizontal line, notice that the y is always 3. So the equation for the line is y equals 3. Let's come back and look at parallel lines on their own. So here are the two parallel lines I drew. One is this guy. I'm going to say that point right there is 4. And its parallel partner, I'm going to say that point right there is 1. And one thing I want you to notice about them is the slope is the same. The slope of this line is exactly equal to the slope of that line. And they have to be equal because that's what keeps them from ever touching. So if I call my first line, let's say the slope is 2. And we know the y-intercept is 4. That's my first line, y1. And my second line, y2, well, I know the y-intercept here is 1, but the slope has to be the same. The slopes are the same, but the y-intercepts are different. And that's all you need to know in order to know that two lines are parallel. If you have two lines with the same slope and a different y-intercept, then they're parallel. With this information, I could ask you to do something like find a line that is parallel to y equals -1/3 x plus 5 and has a y-intercept of 13. And you would say, okay, it's parallel. So let's call this y1. y2, if I know it's parallel, it has to have the same slope. So the slope is -1/3. And it has a y-intercept that equals 13. And I'm done. y2 is parallel to y1, and it has a y-intercept of 13. I could also ask you to find a line that is parallel to, let's see, y1 equals 7x minus 3 and goes through the point 1, 2. So now I'm not telling you the y-intercept, but that's okay because we could either find the y-intercept by saying, I know the slope has to be the same, and I don't know the y-intercept yet, but I'll use my point 1, 2 to help me. When x is 1, y is 2. And so I get 2 equals 7 times 1, so 2 equals 7 plus b. Subtract 7 from both sides, and I get -5 equals b. And that tells me that my formula, y2 equals 7x minus 5. Easy. The key is the slope is different. The key is the slope is the same. The y-intercept is different. And this particular line will go through the point 1, 2. The truth is there's a faster way to do this, which is instead of using slope-intercept form, which is still my recommendation, you could use point-slope form. So I know the slope has to be 7, and the point is 1, 5. So I use my my point-slope form, which I talked about in a previous video. It's m times x minus x naught, then plus y naught. X naught and y naught are 1 and 5. So I get y equals 7 times x minus 1, then plus 5. So this is also an equation of that line. Doesn't take as much work to get, but if you ask me, it's harder to understand what I'm looking at. So I still recommend slope-intercept form. All right, that's parallel lines. Perpendicular lines add another level of complexity. So first, let's look at an example. Let's look at this line here. I'm going to tell you that this line has a slope equal to -2 thirds. Now, let's do -3/2. This line has a slope that equals -3/2. Now, if I take a line that's perfectly perpendicular, the first thing I'm going to notice is that negative slope on my y1, I have a positive slope on my y2. And the second thing you need to notice, so let me write that down. The slope of a perpendicular line has the opposite sign, positive or negative. The next thing to notice is when I look at my rise over run of my y1, and I compare it to my rise over run of my y2, the rise of y1 is the same size as the run of y2. That's -3. And this one is 3. And it works vice versa. The run of y1 is equal in size to the rise of y2. That means the size of the slope is the reciprocal. And remember that reciprocal means flip the fraction. So if the slope of y1 is -3/2, that means the slope of y2 is, well, first I have to make it positive. I'll add a plus sign to make that really obvious. And then I have to flip the fraction, +2/3. So putting all this together, we can say the slopes of perpendicular lines are opposite reciprocals. Change the sign, flip the fraction. So let's practice a couple of those. I'm going to write down a y1, and we're going to find the slope of a y2. By the way, knowing the slope is not going to tell us the y-intercept. So I can write out a whole formula for y1. I can only write out the slope for y2. So if y1 equals 3x minus 7, then y2 has to equal the opposite, which is a negative, and the reciprocal of 3 is 1/3 x plus some unknown y-intercept. If my y1 is -2/5 x plus 10, then y2 is the opposite, so it's going to be positive. Flip the fraction, 5/2 x, and again, an unknown y-intercept. Now I can figure that y-intercept out, I just don't know it yet. if I have a little bit more information. Let's do another one. If y1 is 7/4 x minus 8, then y2 has a slope of negative 4/7. And again, some unknown y-intercept. Now you need more information to find b. And the reason for that is there's a line, y1. There are lots of perpendicular lines that all have an opposite reciprocal slope, but they have different y-intercepts. So you still need an additional point if you're going to find the whole formula. Let's do an example. Find a line perpendicular to y1 equals 7/4 x. Let me use this example. 7/4 x minus 8 that goes through the point 0, 3. Notice 0, 3 is the y-intercept. We're starting easy. So y2 has the opposite reciprocal point, so it must be negative 4/7x plus some y-intercept. And in this case, I know that b equals 3 because I was given that information. So y2 is negative 4/7x plus 3. And I'm done. All right. Let's do another example. Find a line perpendicular to y1 equals negative 3x plus 10 and goes through the point 2, 5. So again, I can start by writing down what I do know. I can find the slope. It should be the negative, so it should be a positive, and the reciprocal is 1/3. So positive 1/3 x plus a b. Probably not going to write that first plus. Let's just write 1/3 x plus b. And I can find b by using the point 2, 5, because I know that when x is 2, y is 5. So I get 5 equals 2/3 plus b. Subtract 2/3 from both sides. Use what I know about fractions. 5 minus 2/3 is 15/3 minus 2/3, which is 13/3. And that is b. So my formula is y2 equals positive 1/3 x plus 13/3. Okay. So we've talked a lot about slope for our parallel and perpendicular lines. Let's come back and talk about slope for vertical and horizontal lines. The slope of a horizontal line is 0. Here's my horizontal line. Let's say that crosses right there at 4. Notice that the y value never changes. It's always 4. And slope is how does the y value change when the x value changes? Slope is change in y over change in x. If the y value never changes, that change is 0. And it doesn't matter what x is. X could be a change by 1, x could be a change by 10. Your slope is always going to be 0. The slope of a horizontal line is 0. The other way to see that is to write it as y equals mx plus b, but we know that b is 4. And we know the slope is 0, or if the slope is 0, it goes away, and that's why I get y equals 4. All right, let's look at vertical lines. The slope of a vertical line is undefined. It has no value. So here's my vertical line. Let's say that point right there is 3. My formula is x equals 3. But notice this vertical line takes on every y value. It takes on y equals 0, y equals 1, y equals 2, etc., and y equals -1. And if it takes on every y value, it is always changing by different amounts. Well, how am I supposed to do change in y over change in x when it's always changing by different amounts? And by the way, the x value is never changing. So I'm trying to divide by 0. We cannot divide by 0, so the slope of a vertical line is undefined. All right, that wraps it up for this video. The last thing I'll say is if you want to decide if a line is horizontal, vertical, or if two lines are parallel or perpendicular, you can look at the formulas. You can look at a table, or it's often really easy to look at a graph. So I want to encourage you to practice all 3 of these ways when you're trying to decide, do I have vertical lines, horizontal lines, parallel lines, or perpendicular lines? Thanks for watching.